So, streetlights. Been pulled up on this so many times that I thought I would give my short opinion on it, and to say, the things that I objectively see as being wrong with this being pushed as the solution to cats jumping in front of me. Why people seem to push this as a solution to perspective, when I don't think it's really cut out to tell the real story here. So for one, as you can see by this particular streetlight situation here, it's as straight as we can come for streetlights. We do have a bit of we have some lights bopping in and out, which is a bit annoying, but it's a good enough example. Most people understand it. This is the sort of stuff they shill all the time. There's a few things that I notice about this sort of thing. So not only do these streetlights seem to converge towards a point, right? They also are spaced differently, and as you can see, it all seems to go down to a point, and everything comes up to a point. So it all depends on where you are seeing these sorts of things. Them coming closer together, basically, I was trying to say to Eric the other day that, let's say streetlights are spaced, 200 yards away. But I mean, this is obviously spaced a lot closer. But imagine if they are 200 yards apart each other, then as it goes further and further away, if everything is evenly spaced, ultimately, as you can see here, it becomes closer and closer and closer and closer and closer. Now, I've done that in two of these images. So as you can see by this particular instance, we've basically got each light is just progressively tighter and tighter and tighter as it gets down to here, where, as you can see, all the street lights are all just a blur. So they're all just so damn close to each other that you can't even tell them apart, right? So that's one thing that goes on with street lights, and when they're trying to space them evenly. And as you can see here, it's a straight line, and they converge. The left is converging to the right, and the right is converging to the left, and even the road here is pointing towards that same location. Now, some people are probably looking at this and saying, well, this is so obvious. This is exactly what the case is. But no. The train track question always gets brought up too. So, we've got the train track on the left that's converging to the right, to the center. And the one on the right is converging leftwards towards the center. And they will reach a point where, optically, they will look like they're touching, even though they may continue on forever and ever and ever and never really touch. But optically, they might come together and clash once in a while. And as you can see here, I've just amplified that thing. So this idea that this answers the question is not 100% correct, because as you can see here by all the sleepers, as you can see this, you can clearly see the rocks in between the sleepers, and as it gets further away, you can't see the rocks. The sleepers almost become a blur as well. All the sleepers all start to look like they're all joined together. Now, star trails. They're all trying to say that this explains the way the sun is setting. So in a particular part, it's almost like they're imagining, let's say you're in northern hemisphere. This one explains the northern hemisphere because all the street lights are going in that direction. And if you're in southern hemisphere, they're all going in this direction, which explains the southern hemisphere. No, not at all. Not at all. So look at these star trails. Now, many flat earthers have seen this before. They don't know what they're looking at because the most oddest thing about this, as you can see, is this could be in Australia, and this could actually be the Australian star trails coming down. I can't really quite tell which direction that star trail is going right now. I don't know if it's going up or down. I'm not too sure. But either way, can you see that the star trails are not converging? Every single one of them is not touching the other. They might look close, but they're not actually converging at all. It's not like the star trail from over here is converging towards here, and the one from over there is converging towards there, is it? No. These star trails, none of them converge. They're all on their own personal track. as you can see. So that in itself does not correlate with this train track theory, right? The fact that stars never converge. But this is somehow explained as being the correct answer. The sun. Now, as I've seen from Dave Weiss, he goes out there and says basically this is all passing down, just like the train tracks. Not the case. It is pitched, as I've said many times. It is pitched at the exact angle of your latitude. So, if you're 30 degrees south, it's going during equinox is going to be tilted over 30 degrees from the zenith. So if the zenith is straight up, you pitch over 30 degrees, that's the angle that it comes down at. So this angle right here is going to be like, say, 30 degrees if you're at a zenith, if you're at a latitude of 30 degrees. So this train track theory it's a kid's answer. That's what it is. It's a kid's answer. It's not a good enough answer. It doesn't literally explain anything at all. If anyone seriously wants to go out there and figure it out, you go out there and you plot the angle of the train track, and then tell me how it relates. Because what you'll see is as it goes further and further and further, for every millimeter of distance, it travels further and further and further in distance, from like millimeter on the actual photo. So it just doesn't work that way. I hope I haven't. I hope I've made sense, and I hope it's very, very clear that these star trails don't converge like these train tracks do, and the sun does not converge either because it's on its own path. You need to go to an entirely different point in the planet to be able to see the sun going in the opposite direction, and that's going to be latitude dependent. Thanks for listening.